Hey guys, it's Eddie the Magic Monk. In this lesson, we're going to look at a practical problem where you have to find the area of an irregular shape using mid-ordinate rule, and you also need to find the scale factor of the map first. So how do you do this question? Well, basically we have a area of some sort of shape. You can imagine it to be a suburb or an island or a small island or something like that, a top-down view of an island, and we have the length from one end of the island to another measured in real life to be 20 kilometers. So the first step would be to find the scale factor, because without the scale factor we cannot measure anything else on this map. So we need the scale factor, and the scale factor is written as the plane length to the field length. Plane length to field length. So the field length is the measurement in real life, and in this case it's 20 kilometers. But the plane length, we don't know what it is, so we need to measure that with the ruler, which I'll bring up now. And you can see on the ruler, I might just make it a bit more obvious for you guys. On the ruler it says it's 10 centimeters. The survey line is 10 centimeters. So I'm gonna write down 10 centimeters on the ruler. So if it's 10 centimeters on the ruler and it's 20 kilometers in real life, what is the scale factor? Well, in order to get the scale factor, the first thing we need to do is to convert both sides to the same units. So one side is kilometers, the other side is centimeters. So let's choose the smaller unit to keep things simple. So 20 kilometers, how do you convert that to centimeters? Well, kilometers to meters, you would times it by 1,000, right? Because 1 kilometer is 1,000 meters. From meters to centimeters, you would times by another 100. So it's 100,000. So you're going to write down the number, plus you're going to insert 5 more zeros, 1, 2, 3, 4, 5 centimeters. And now you don't write the units anymore because they're the same units. So then what we do is we're going to divide both sides by the same number so that the left hand side becomes 1. So 10 divided by 10 is 1, and right hand side divided by 10, well, you just cross off another 0, so it's 2 0 1 2 3 4 5 zeros. Okay, because there are 6 zeros here. So it's 1 to 200,000. So what that means is 1 centimeter on this map is 200,000 centimeters in real life. Okay, so now what we're going to do is we're going to use the mid-ordinate rule, and it says we're going to use the mid-ordinate rule with 5 segments. So what that means is we're going to divide this survey line into 5 segments. So let's bring up the ruler again. Let's bring up the ruler again and just move it to where the survey line is. And we're just going to draw 5 segments. So we got, each segment is 2 centimeters because the whole survey line is 10 centimeters. So I might just write that down. The width of one segment equals 10 centimeters divided by 5, because we want 5 segments as stated in the question. If the question says 10 centimeters, we would divide this by 10 and so on. So each segment is 2 centimeters, so let's use that to break it up. So we got 2, 2, 2, 6 plus 2 is 8, so we got 5 segments. And now we can draw a vertical line, down at each segment. Okay, so we got 5 segments, which is great. Okay, but what does the mid-ordinate rule want? The mid-ordinate rule wants you to draw some mid-ordinate lines in the middle of each segment. So in the middle of each segment, which is about here and here and here, we're going to draw the mid-ordinate lines. So how will we find the midpoint of each segment? Well, in this case it's easy, because if we have each width is 2 centimeters, midway point will just be 1 centimeter. So I'm going to mark that out with another colored pen. So the middle of each segment, let's write them out. Okay, so I have the middle of each segment, and now we're going to, oops, I shouldn't have drawn them on that layer. Hang on a second. So I'm going to draw the mid-ordinates. These are in the middle of each segment, and these are the lines that we're going to measure with our ruler. So now we need to get the vertical ruler out. If you are doing this on paper, you probably have it out already to draw the line straight. And now we're going to measure, oopsie, now we're going to measure each line and write the measurements down. So the first one is 2 centimeters, and then we have 2.8, 4.5, 4.2, and 2.8. So we have all of these mid-ordinate lengths, and the next thing we want to do is we want to convert them to real life lengths, the field lengths, because right now they are just plane lengths. They're how long it is on the plane. So to get the field lengths, all we're going to do is we're going to multiply each of these numbers by 200,000 as suggested in the scale factor, because scale factor tells us that 1 centimeter on the plane is 200,000 in real life. So 2 centimeters on the plane is how many in real life? Well, it's 2 times 200,000, and we're going to do the same to each of these. So we got 2.8 times 200,000, 4.5 times 200,000, and we're going to do the same to 4.2 and do the same to 2.8. Okay, so let's all find the answers to these numbers. So these are the real life lengths, and they are still in centimeters, because all we've done is we've multiplied the plane lengths by the scale factor, but we haven't converted the units yet. We've just found how long they are in real life in centimeters. We need to convert them into the units we want to work in, and you can see our survey line was measured with kilometers. So I'm now going to convert each of these numbers to kilometers. So how will we do that? Well, I'm just going to get each number, and I'm going to, if you guys remember, going from kilometers to centimeters, we multiplied by 100,000. So to go back, we need to do the reverse. So we're going to divide it by 100 and then divide it by 1,000. So it's the same as dividing it by 100,000, which means I just basically cross off 1, 2, 3, or 5 zeros. So I'm just going to write the final answer in kilometers next to each of these numbers. So that's equals, cross off 5 zeros. That's just 4 kilometers. and cross off 5 zeros, and the last one is not a 0, so we simply move the decimal point to over here, so it's 5.6 kilometers, because you go, what we're really doing is we're moving the decimal point from the end to 1, 2, 3, 4, 5. Okay, so the new decimal point is here. Okay, so now we're going to do the same thing, and this would be 9 kilometers. This would be 8.4 kilometers, and this one would be 5.6 kilometers. Okay, so now we can use the mid-ordinate rule, which is the area equals sum of the mid-ordinates divided by n, which is the number of mid-ordinates, times by L, which is the length of the survey line. So let me write those down. M is the mid-ordinates, lengths. N is the number of mid-ordinates, and L is the survey line length. Okay, so we're working in kilometers, so let's just add all the numbers together. So we have 4 plus 5.6 plus 9 plus 8.4 plus 5.6 divided by n, which is 5 because there are 5 lines, times by L, and L, which is the length of the survey line we said before, is 20. Okay, so now we just need to type all of this into the calculator. 4 plus 5.6 plus 9 plus 8.4 plus 5.6 divided by 5 times 20, and you got 130.4. 130.4. And what are the units? We worked in kilometers, so it's kilometers squared. Okay, so that's how you do a problem with the mid-ordinate rule and a scale factor problem combined. Thanks for watching, guys. See you next time.